Alrighty, so let's look at these. Good morning, welcome. Number 1, no tally marks. Good job, guys. This one is false. So if this is not correct, what should go there? What should go on the right-hand side? If we were going to simplify it or write it as something that is true. Yes, ma'am?
Put a parentheses around the first one.
Oh, if I was to, do that?
Yeah, or to remove the parentheses.
Or to remove the parentheses here. Absolutely, either one of those would make it true. Can anybody else think of another way that we could write the right-hand side so that it would make it true? There's more than one available option here. Yes, sir.
You could put the left-hand side, all of it in parentheses, and multiply it by -1.
Let me see. I think I understand what you're saying.
Yeah.
Left-hand side, all inside parentheses, and multiply it by -1.
Yeah.
Yes. That would make it equivalent. Did you have an idea?
I was going to rewrite the right side as -1, then parentheses 7, and parentheses squared.
That would absolutely work as well. Yes. So there's more than one right way to write it so that it's an identity. An identity is when the two sides are the same no matter what, whether there's variables involved or not, they're always going to actually be equal. That's what I mean when I say identity. All right, number 2. Good job. We've got 6 people. This one was true. And not because they're wrong, but just so you can see true. I'm going to erase these 6 marks, but good job. So there's a couple ways that you could look at this one. I know some people just love logs, and I'm saying that as facetiously as possible. Just full disclosure on logs, it took me until my sophomore year in college to actually understand them. So if they still feel mysterious, spooky, scary, that's not unusual. Logs are a weird bird. You guys started working with them in Algebra 2. It's mostly understanding the mechanics because, like I said, it is a very complex topic. We will touch on logs in here again, and hopefully when we go through it again after you've already seen it in Algebra 2, it will make a little bit more sense. My hope is that all of you guys will have a better understanding of it before your sophomore year in college than I did. But with logs, we can use powers property. I can take this exponent of 3, and this is one of my properties of logs. I can bring it down in front, drop it down as a multiple, so this would become 3 times log 10. What is the base on this log? 10. Yes, this is common log. If you don't see a number and it's not ln, it's understood to be 10. When the base of the log and the argument, that is my large number there, the 10, when those match, what does it simplify to? 1. And so in that case, this would become a 1, and so we have 3 times 1, which is why it's equal to 3. Number 3 is false. Number 3 is false. And this one tripped up a bunch of people. We are going to be digging more into exponent rules tomorrow and Friday, so we will have a good refresher on these. So with our exponent rules, if I have a to the m times a to the n, that's when I add the exponents. I'm multiplying 2 of the same base. I add my powers. That is equal to a to the m plus n. This one right here, when I have a power and parentheses and then another power on top of that, we multiply our exponents together. So this would be m times n. That's one that trips a lot of people up. One of the things that you could always do if you're unsure, especially if it's a test or a quiz and you've got time to go back and double check things, you could always try this with some numbers. Stay away from 1s and 2s. Those are tricky with powers, but you could do it with another power, like say 3 squared. If I took that then to the 3rd power, I could always test this in my calculator. Is that the same as 3 to the 5th or 3 to the 6th? And then I would know whether I'm multiplying or adding. Does that help? Cool. Number 4, we have 2 people that think this one is correct. Unfortunately, it is not. It is almost correct. So even though we don't see them, the numerator is assumed to have parentheses around it. So order of operations, since I can't simplify inside the parentheses, then I would divide everything in my numerator by that denominator. So the x gets divided by the 5, as well as the 5 getting divided by the 5. So the plus 1 is fine, but this first piece should either be x divided by 5 or 1/5 x. That would make it a true statement. Number 5 is also false. And please don't feel bad if you've missed most of the ones that you put a tally mark up here for, like it says up at the top of the page. These are common mistakes. That's why we're kind of going through them right now, getting a refresher on some of these things. So the problem with number 5, and the reason that that one is false, is that my square root is technically a power. Square roots are the same thing as a 1/2 power. So when I think about my order of operations, underneath that radical, we have addition and subtraction. Exponents do not distribute over addition and subtraction. It's not distributing, but you can kind of think of it like distributing. Exponents can distribute to each piece if my terms are being multiplied. Like 3x whole thing squared, that's the same as 3 squared and x squared multiplied together. Here, when I have addition and subtraction underneath a radical, I cannot distribute this at all. This has no other way to write it other than x squared plus 4. There is no way to further simplify that particular one. So if I had to rewrite the right-hand side to make it equivalent, I only have one option there. Or I suppose I could get fancy and do 1 times. Number 6 is false, for the same reason that number 5 is false. Yes, sir?
Could you put plus or minus on number 5?
Put plus or minus. No, I see where you're going with that, and we will look at certain situations where we could have a plus or minus on the other side of this page when we were doing squaring binomials. If you'll notice, some of the ones that had negatives inside their parentheses before we squared them, when we simplified that, we did end up with only positives, so we could have rewritten that with both positive signs instead of 2 negatives. But in that particular instance, we cannot. Like I said, there will be other times that we can, and I'll make sure to hit on that when we can. Number 6, like I said, is false. This one would just be square root of a plus b. Again, powers cannot distribute over addition and subtraction. Number 7 is true. Good job, guys. Number 7 is true. Yeah, 6 people get that one right again. So to see why this one is true, you have to factor underneath the radical. How does x squared plus 6x plus 9 factor? X plus 3, x plus 3. So I could write that as x plus 3 whole quantity squared. So because I have a binomial inside parentheses and that whole binomial is being squared, here the squared and the square root would cancel each other out. It doesn't require any kind of distributing of that. Three more to go. Number 8 is false. I don't know why I write my capital F's up like backwards. It's a thing that I started years ago. I'm not sure why, but that's just a capital F. Why is number 8 false? What can I change? Sorry, let me change my question. What can I change about the right-hand side to make it true? Yes, sir.
You can just take the x out of the denominator.
Take the x out of the denominator. As it was written right now, x squared over 2x, well, that's x times x over 2 times x, and that can simplify, correct? I'd have my x's cancel out. That would just be x over 2. That is not the same as x times x over 2, because there's nothing there that would cancel. When we multiply whole numbers, in this case, that would be symbolized by our x out in front, to a fraction, you are multiplying only the numerator part. Because remember, we can take any whole number and turn it into a fraction by doing what?
Over 1.
Over 1. And the way we multiply fractions? Yep. Top to top, bottom to bottom. Number 9 is also false. There's one very small thing that I would need to change on the right-hand side to make it true. What's the only thing making this false? The negative. Negative exponents turn something into the reciprocal. They do not affect the signage. It will not change it from a positive to a negative or otherwise. Oh, hello. So if I get rid of this, now it's true. And last one. Good job, guys. We got 8 people there. This one is true. Nice work. Similar to number 4 back here, where we talked about that numerator's inside parentheses, so I'm dividing both pieces of that binomial by the denominator. That's exactly what they're showing here. You have x squared divided by negative 10, and then they move their negative up to the top. By the way, when we talk about negatives with fractions, if it is a negative fraction, you have how many negative signs there? 1. Where can the negative sign be and still be correct? Front, on top. If you put it on bottom, as long as that's not your final answer, that would be fine. Depending on the concept we're working on, if you leave it down in your denominator, I'm probably not going to count it wrong because that's probably not the concept that I'm assessing there. But standard practice in mathematics is if we have a negative fraction, it goes up with your numerator or it goes out in front. And then 5x divided by negative 10, and they simplified that as well. Awesome. Awesome, awesome. Okay. Grab your notebooks. Hopefully everybody has a notebook with paper. If you do not, I've got some paper that I could probably give you for today. We are going to fly through section 1.1 today. There will be a homework over this that is due tomorrow. All of my homeworks in Canvas, by the way, are due at 11:59. So when I say it's due tomorrow, you've got all today and all tomorrow to get it done and still stay on track. Does anybody need paper? Actually, there you go, take out what you need. Does anybody else need paper? All right. Here we go. We are going to talk about real numbers today. Did anybody notice my meme at the beginning?
I did.
You did? Does anybody know what the meme is from?
Yes, it's very old.
Yes, it's insanely old, but it was the only one that I found that was even somewhat amusing that had to do with real numbers. So I decided to go with it. Real numbers are made up of what two types of numbers? It is up there, I promise. Real numbers are when I take two different types. Rationals and irrationals, absolutely. Rational and irrational numbers together make my set of real numbers. Irrationals, we're going to leave alone for the time being. Irrationals would be things like the square root of 2, where it does not repeat, it does not end. Pi is another example of an irrational number. Rational numbers are made up of two types of numbers. We have integers. What do I mean by integers?
It's whole.
Whole numbers, positive and negative whole numbers, also including 0. And then we've got our fractions. Underneath our integers, obviously, I just mentioned this, we've got positive, negative, and 0. Why does 0 go up there by itself?
It's not positive.
It's not positive or negative. It is literally the dividing line between positive and negative numbers. So it does not fall into either category. All right. I'm going to go ahead and pop the next slide up. If you need to grab a quick screenshot so that you can finish copying this down into your notes, feel free. I do also post the notes every day just in case I go too fast. You do not need to copy down this next slide at all. We're just going to talk about some basic notation and terminology. What does reciprocal mean? I mentioned it earlier, but I didn't actually state what it meant.
The opposite of the fraction.
Flip it over, yes. Flip it over. Totally understand why you said opposite. I do just want to point out that when we say opposite in math, often we're talking about the sign. And please, nobody get offended if I make these minor corrections. I just want to make sure that when we use certain terminology in here, we all have the same understanding of some of these different vocabulary terms. What's the difference between an equation and an expression? Yep, yeah, feel free to shout it out. Sorry, guys.
Equations are made up of expressions and or combinations of a equality sign
Mm-hmm.
and multiple term or expressions.
Yes. So expressions can be contained, can have one single term, just like 5 is an expression. X is an expression. 5 plus X is an expression. As soon as we have two expressions with an equality in the middle, then we have an equation. Talk to me about these 4 symbols up here.
Greater than or equal to, less than or equal to.
Absolutely. Absolutely. And now I'm going to tattle on myself again. I was way too old. See, I wasn't in college, but I wasn't in junior high anymore before I actually knew that those symbols had different names because I still just did the alligator eats the bigger thing. Totally works. Difference between these two.
Approximately equal to and equal to.
Approximately equal to, equal to. When is it appropriate to use an approximately equal to sign?
When you're rounding.
When you have had to round. If you forget on your work and you put an equal sign and you write 0.33 and the answer was 1/3, I'm not counting you wrong. But I do want you to be familiar with all the different notation. What's going on here?
Absolute value.
Absolute value. What does absolute value do?
So it's everything, so it's opposite, so it'll all be positive.
They will all be positive. Did you have something to add? That's absolutely correct. It's distance. Distance is always a positive value, and it tells us how far from 0 we are. So it is always going to be a positive value. You're correct. And then what are these two guys?
The square root.
Square root and 6th root. Nice work. Oftentimes we will use a word that starts with an R to refer to either one of these. Radicals. Sixth root, index is 6 here. What's the index on a square root? 2. Fantastic. All right, we're going to work just on some sign stuff here. So A through E on this example. I want to know if the final answer here would be a positive number or a negative number. And here is what we've been given to work with. It says x is less than 0, which means it is what type of number? Negative. And y is positive. So x is a negative number, y is a positive number. If I take those two and multiply them together, the result will be negative. What about if I take x and square it and then multiply it to y? Positive. If I take y and divide it by x? Negative. On any of these, if you're unsure, substitute some numbers in instead of x and y. Pick a positive number. Pick a negative number. See what you get. If I do x divided by y, and then I add x, negative. Why negative?
Because that's about y is negative, so add the negative to another negative.
Absolutely correct. X divided by y is a negative, just like y divided by x is a negative, and then I'm adding another negative number to it. What about y minus x? Positive. I have a positive number, and then I'm subtracting a negative number, which would give me a positive. Nice work. All right. We are going to practice now taking some verbal expressions and changing them into symbolic expressions. So how would I write x is negative as an inequality? X is less than 0. Less than or equal to? No. Not less than or equal to. It's stated very specifically that it is negative, so it cannot be 0. Y is non-negative.
Y is greater than or equal to.
Y is greater than or equal to 0. Some kind of not negative number. 0 qualifies as not negative. Q is less than or equal to pi. Q, pi. Which one is the alligator eating?
Pie.
Eating pi. Less than or equal to. There we go. D is between 4 and 2. So should I write and then put my inequalities?
B is less than 4 greater than 2.
Yeah. So I want 2 first, then I want D, then I want 4. When we're writing an inequality statement, I always want the smaller number farther on the left, larger number farther on the right. D is between these two. Did it say it could be equal to either one? No, it said it was specifically between, so I've just got my less than symbols in here. T is not less than 5. T is greater than or equal to 5. The reciprocal of W is at least 9. 1 over W is at least
Is
greater than or equal to 9. Yes. The reciprocal of W, so 1 over W, is at least this big. It can be bigger. And then the last one, the quotient of P and Q is at most 7. P over Q. Oh, that was my lovely door. Sorry, there's a spring there that decides to act up sometimes. Quotient of P and Q. So P over Q is at most 7. I apologize. I don't remember after the spring went which way we said this was. Less than or equal to. It can be no bigger than 7. You guys okay on those? Cool. Absolute value stuff. And then we are almost done with this. We've got 2 more slides for our notes today. So I want to practice rewriting these without the absolute value before we evaluate it. And that's to prepare us for the next slide, because there we're going to be looking at these that we have to write without the absolute value, but it has variables. So that's why I want to practice it this way first, because we have a way to mentally check whether or not it's correct. So I want to know, if you do -4 minus 5, what would that result be? That's going to give me a negative result, right? So what is the absolute value going to do to it in effect? It's going to make, how do I take something that's negative and make it positive without absolute value? Could I multiply it by? -1. So I can rewrite this, since I already know what's inside is going to come out negative. I can rewrite this without the absolute value sign by multiplying it by -1. And I have the exact same result as the absolute value. So far, so good? What would this evaluate to? 9. How could I rewrite B without using the absolute value sign so that it would evaluate the same way?
And you -1 times -1 instead of -9.
And then -9. So how would that evaluate? -8. You guys okay with the way I'm thinking through this so far? Again, we're practicing right now just how do I rewrite it if it's a negative, but I know absolute value makes it positive, because in just a minute we're going to do this without just numbers in there. Tell me how to rewrite part C.
3 plus -1 times
What happens when I add a negative? That's subtraction. So I could have also written 3 minus -2. That would be another equivalent way of rewriting it. I'd take either one. And this whole thing would evaluate to give me what? 5. How would I rewrite part D?
-5 parentheses 4 minus 3 minus -1 times -8.
Yes, that would absolutely be one way to do it. You could clean it up from there if you wanted to. You could have -5 times parentheses 4 minus 3 plus, and then in parentheses -8. That would be fine as well. How is this going to evaluate for us? -13. And last one on this screen. I have absolute value of -10 divided by -2. How do I rewrite this without absolute value so that it evaluates the same?
-1 times -10 over -2.
And this evaluates to?
-5.
-5. All right. Last piece for today. Same skill that we were practicing here. Now we're going to be looking at this with some absolute values that have variables, and they have to give us a little bit of information about that variable, or else I don't know if the inside is going to evaluate to be a positive or a negative. On part A, if x is less than -2, would this evaluate to be a positive or a negative number? This is going to evaluate to be a negative. If it is smaller than or to the left of -2, this is going to evaluate to be a negative number. So how would I rewrite this then without the absolute value, knowing that it would come out to be a negative on the inside?
-1 times 2 minus x or plus x.
It'd be 2 plus x if I write it with the parentheses. But I like what you were doing at the end there, because I would want you to then distribute this to finish answering that. Your answers in here do need to be fully simplified So I would want -2 minus x. Or if you're in the habit of always putting the variable first, you could have -x minus 2. Either one of those would receive full credit. The one with the parentheses would not, because that is not a fully simplified final answer. If x is greater than 5, would this whole thing in here simplify to be a positive or a negative? It's going to simplify to be a negative, yes. If you're in doubt on these things, pick a number that satisfies that inequality over there. Substitute it in and see what happens. 10 is bigger than 5. 5 minus 10 comes out to give me a negative. All right, so tell me how to rewrite this without the absolute values.
-1 times parentheses 5 minus x.
And so fully simplified,
Be negative, or x plus, or x minus 5.
x minus 5. Can you guys think of another way to write that that would still be correct and fully simplified? -5 plus x. Nice work. I want you guys to try C and D on your own, and we'll check those here in just a moment. Part C, fully simplified. What would this look like?
X plus 9.
X plus 9. And part D, fully simplified. Negative m plus n, or n minus m. Either one, both are fully simplified. I'd accept either of those. All right. That finishes up section 1.1 for us. You guys feeling okay about this one? Okay. You have a homework assignment tonight. From the book, it is 7 problems. You'll notice that like some of the questions in the book have parts A, B, C, D, E. So in Canvas, each one of those parts has a question, but it's very similar to what we went over here today. Down at the bottom of the page, for our daily page, that's where your homework is linked. I'll just give you a real quick preview of this. All right, like I said, unlimited attempts, due tomorrow. Remember, everything is due 11:59 p.m. You should be able to get this knocked out today, no problem. I would definitely recommend staying on top of your assignments. So like right here, we've got parts A, B, C, D, and then I rewrote those here, and you're just telling me like that first example, are they positive or negative, given the constraints that we have on X and Y, all right? If there's anything you don't understand how to do on the homework, let me know. Also, please keep track of your work on a sheet somewhere because I do want to see your work at the end, okay? Those handouts that came around, this is the other thing that I need you guys to work on. This is setting up your IU, Indiana University IT, Information Technology account. You need to go through and do this whether you are taking this course for dual credit or not. This is for anyone in this course, even if you're not trying to get IU credit for this course. Okay?